Hello, and welcome to Shane's Microscope. I'm Shane, and this is my microscope. Let's take a peek. Today's sample comes to us from my fireplace, which, incidentally, is my cat's favorite thing in the entire house during the winter months. Now, I can't put fire, of course, in my compound microscope, but I can put ashes in, and I figured it would be useful to look at some pre-ash material first, so I got a little sawdust on there, but I've also got some dark ash and some white ash for us to investigate. So under the microscope now, we're looking at unburned wood. Wood has Germanic roots, and English being a Germanic language, it means what you think it means. But looking at this wood, we can see that the particles definitely have a very splintery nature. They have a definite, recognizable morphology to them. And under higher magnification, we can see that as well. A lot of these pieces are thin enough to look almost glass-like. There are a few thicker pieces that definitely have some wood-like color to them, but most of the pieces are pretty transparent at this scale. And that holds true at even higher magnification. Now, interestingly, if you look at this piece, there's kind of a little purple thing in there, and there's a whole collection of them in this piece. I'm wondering if those are the dried up insides of plant cells. I mean, wood is, of course, composed of cells, and when those cells are dead, I would expect them to shrivel up in there and leave some remains. Now, looking here at the sample of the darker ash, ash being another word of Germanic origin that means what you think it means, we can see some dark, sort of blob-like structures. Ash is what's left behind after combustion, and given the temperatures that a fireplace operates at, the combustion is not complete, and so there's going to be leftover carbon. And of the inorganic fraction, calcium carbonate at these temperatures is the major leftover material. And of course, there's a multitude of other oxides that are left over from combustion. Most of the darker stuff is probably carbon-containing compounds. And here at really high magnification, we can see that we've got a variety of particle sizes. Again, still that huge blob on the left, but a collection of particle sizes scattered about. And now we're looking at the white ash, and we can already tell that the particle sizes are much smaller than they were in the other sample. That's because the white ash is a result of a more complete combustion, and so there's a lot less carbon in this, which is why it doesn't have that dark color. This is going to be mostly a calcium carbonate, which is white. And under the higher magnification for the white ash, we can see that that continues to hold true. These particles are much smaller than they were in the darker ash sample. And under my highest magnification, we can see that mostly it's just very small particles. There are a few larger clumps of material, but mostly it's small particles. So I think this is really interesting because this means that looking at a sample of ash, we can get an idea of how complete the combustion was, which will ultimately tell us something about the temperature that it burned at. Yeah, I think we'll leave it there for the day. Thanks for having a look with me. Until next time, keep on peeking.